Welcome to The Explainer. If you're a technical decision maker, an engineering lead, or a business strategist working with AI, you know the drill. You've probably seen AI generate some brilliant insights 1 minute and then literally break your downstream data pipelines the next, and it's usually right before a major product launch, right? Well, today, our mission is to fix that. We're going to transform AI from a wild, creative chaos engine into a precise, reliable data processor. Let's jump right in.
So why do these incredibly powerful AI models still manage to break our pipelines? It's the multi-million-dollar question, isn't it? You wire up a state-of-the-art language model, and on the surface, everything looks fantastic. But then, silent data corruption sneaks in. A trailing comma here, a totally hallucinated category there, and suddenly your business dashboards are displaying absolute nonsense. Sometimes it takes a week for anyone to even notice. By then, your data team is dealing with a full-blown 2 a.m. emergency. The engineering hours burned are staggering, and honestly, the trust you lose with stakeholders, that takes way longer to repair.
To solve this, we'll be using the CLEAR method framework: context, limits, examples, action, and results. Consider this our exact strategic roadmap to stopping those pipeline failures for good.
All right, starting off with Phase 1, context, the AI pipeline gap.
Here's the fundamental disconnect. Large language models speak amazingly fluent, creative, free-form text. But your APIs, your SQL databases, your core services, yeah, they don't care about creativity. They demand rigid, structured data. And the ambiguity of text is exactly where pipelines snap. When an AI's fuzzy output becomes your system's input, you absolutely cannot rely on best guesses. If an LLM drops just one closing bracket or decides to spell out the word 5 instead of using the digit 5, your entire parsing logic falls apart. You can't leave it to chance when a single missed character can crash a financial reporting system. You need something you can validate and query with 100% mathematical certainty.
Enter structured outputs. Think of it like this. Instead of asking a new employee to write a sprawling free-form essay about what they did today, you hand them a super strict fill-in-the-blank form. By forcing the AI to return data in a predictable, machine-readable shape, like JSON, you're creating an ironclad data contract. The model stops acting like a creative writer and starts acting like a reliable, auditable data processor. This is absolutely essential for enterprise compliance. You know exactly what fields are coming back, you know the data types, and you can programmatically verify the whole shebang before it touches your business logic.
Moving on to Phase 2, limits, unstructured output risks.
Let's contrast these two approaches real quick. Raw prompting is incredibly creative, sure, but it's wildly unpredictable and frankly impossible to measure programmatically. Structured outputs, on the flip side, are constrained, predictable, and totally measurable. Imagine you're automating high-value customer support tickets without human intervention. Actually, scratch that. In any automation scenario, AI creativity is your enemy. Predictability is your best friend. If the model gets creative and invents a new routing department that doesn't even exist in your directory, that ticket drops right into a black hole. Setting structured limits prevents that entirely.
Because what is the actual business cost of that creative chaos? It is massive. When a model decides to be helpful and adds a little conversational pleasantry to a data payload, your code breaks. You end up with silent data corruption, your downstream reporting dashboards go offline, and worst of all, you bleed expensive engineering hours debugging pipelines that worked perfectly fine during testing. Engineers shouldn't be wasting time writing complex regular expressions just to guess what an AI meant. They need to be building new revenue-generating features.
That brings us to Phase 3. Examples: fixing broken AI.
So how do we fix it in practice? Take a look at this iterative feedback loop. When a model writes code or generates JSON that fails, the system doesn't just crash and throw a 500 error to the user anymore. Instead, it grabs the compiler errors, the runtime failures, and the test case feedback and feeds it directly back to the model as a new prompt. The LLM gets a chance to try again, knowing exactly why it failed. It's like having a senior developer instantly review a junior dev's code, pointing to a specific line and saying, "Hey, fix the syntax error and resubmit." To put that into perspective, look at the sheer scale of improvement here from the archive study. For GPT-04 Mini working in Python, the baseline success rate on the very first try is roughly 31%. But when you add that iterative feedback loop into the mix, that orange data point, success skyrockets to over 81%. That is a massive leap in reliability just by automating a feedback mechanism. We aren't changing the model and we aren't retraining it. We're just giving it structured limits and a chance to self-correct, using its own errors.
Now, the study found that syntactic and runtime errors are the absolute easiest to fix this way. But here's the catch for you decision makers. This works best with reasoning models. Models equipped with chain-of-thought capabilities like DeepSeek R1 or GPT-04 Mini consistently get better over multiple iterations. Non-reasoning models, they just plateau and keep making the exact same mistakes. So if you're planning your tech stack and making purchasing decisions right now, picking the right reasoning model architecture is absolutely crucial for this self-healing loop to actually yield business value.
Moving right along to Phase 4, Action, Schemas and Feedback.
This right here is the workhorse architectural pattern your teams need to implement for any production pipeline. Step 1. Validate the AI's output against a strict schema before you even think about trusting it. Step 2. If it fails, do not throw an error to the user. Instead, repair it by sending those validation errors right back to the model. And Step 3. Retry the generation safely. This loop catches structural drift before it ever hits your database. You're taking a silent, catastrophic failure and turning it into a handled, self-healing event that your users never even notice. This is exactly how you build resilient enterprise AI.
And the really great news is, in 2026, you don't have to build all of this from scratch. Every major provider now ships native structured output enforcement. OpenAI has strict mode, Claude uses output_config.format, and Gemini uses response_JSON_schema. This means the model's token generation is literally mathematically restricted at inference time. Only schema-valid tokens can be produced. And because this is now a reliable, industry-wide standard, you aren't locked into a single vendor. It gives you incredible strategic flexibility to swap models out whenever pricing or performance changes.
But here is a super critical piece of actionable advice to take back to your engineering teams. Use enums. If your system routes work based on a specific field, lock it down tight. Instead of letting the AI make up a priority string like billing issue urgent, force it to choose strictly between predefined options like low, medium, or high. If the model hallucinates a category called super duper urgent, your routing logic crashes. Forcing it to choose from a rigid list absolutely kills creative routing values and ensures your downstream systems keep humming along flawlessly every single time.
Finally, we arrive at Phase 5, Results, Reliable Business Value.
When you finally bridge that pipeline gap, the enterprise applications are immediate and, honestly, highly lucrative. Think about flawless invoice parsing directly into accounting systems like SAP with exact key-value mapping. Say goodbye to manual data entry. You get perfectly routed support tickets based on constrained labels, drastically cutting response times. You get auditable metadata for your internal search tools, making your proprietary data actually retrievable. You can even automate security audits with structured, quantifiable risk findings. This approach fundamentally takes AI from being a fascinating novelty and turns it into a rock-solid workflow engine that drives massive ROI.
I really want to highlight this fantastic insight from AI engineering lead Colin Wilkins. He says, boring schemas scale, interesting schemas break. It's so tempting to let AI handle these incredibly complex, deeply nested data structures because it feels like a great way to capture nuance. But trust me, simplicity and strict constraints are the true keys to enterprise reliability. The flatter and more boring your JSON schemas are, the faster they process, the cheaper they are to run, and the less likely they are to hallucinate in production. In business, boring is profitable.
So, what does this all mean for you? It really comes down to a choice. You know the risks of raw prompting, and you now have the CLEAR framework, context, limits, examples, action, and results as your blueprint for implementation. Are you going to let AI create silent chaos in your pipelines, or are you going to build the strict structures that actually scale your business? The tools are right there, ready to go. It's time to build. Thanks for joining me for this explainer.